Hey everybody, glad you could make it. Today we're going to talk about manufacturing reinvented. Now this is a presentation you would normally see at a Forged tour, which is one of our local events at various offices and locations around the country that feature not only our people at MLC CAD Systems, but also the printers themselves so you can get hands-on. So if you're watching this as a video, get your hands on some of these parts and you'll definitely see what we're talking about in terms of some really nice structural parts. MLC CAD Systems is who I work for. We are a value-added reseller of Markforged, SolidWorks, and Mastercam. We have offices in all the locations shown in the map. We have 24 offices. We've been in business for 40 years, but Markforged hasn't. So we've picked that up in the recent past. I'm going to talk today about kind of the basic 3D printing landscape, tell you quick information about Markforged, what it looks like when you pick up a Markforged printer. We'll talk about some examples and an overview of the solution, and then feel free to reach out for discussion or Q&A at any time, or reach us in the comments of this YouTube video. So I want to tell a story real quick about an adoption of a new technology. Now, this is one that happened many years ago. This was the decline of steam engines and the increase in the use of electric motors in factories. And if you can see on the left here, this first graph talks about when electric motor usage or sales sort of overtook steam engines and became the dominant force in the manufacturing power industry. That's around the year 1920. And as you can see, there was no going back, right? This was clearly the superior way to do it, and things looked great from that day forward. However, if you look at the graph on the right, productivity in manufacturing, you can see that productivity was kind of slowly going along, probably just a remnant of all general labor productivity increases, but the ROI dropped. Because the early adopters had to pay for the tooling for all the motors, the buildup of the machine, the R&D to get the motors fabricated and make them more efficient and more powerful, because all of that was happening, the ROI really ended up being not that great. There was so much additional infrastructure investment required to get the electricity, to buy equipment that would run on electric motors instead of steam. And so for about 2 decades, it was kind of a losing battle, but it was definitely worth it in the long run. But after that inflection point, the ROI started to become fantastic. And very soon it surpassed the productivity or the ROI that we've ever seen before. So it was definitely the right move, but there are some sort of growing pains related to the time frame. So to overcome the constraints of steam power, factory owners had to shift their thinking. And that's what we're talking about today, is shifting your thinking to see how additive manufacturing and 3D printing can help you add value. Now, I'm not suggesting you're going to drop a technology entirely in order to adopt 3D printing, but it's going to be a fantastic add-on that's really going to help you out. So in comparison to the steam engine decline, let's talk about the sort of the adoption of 3D printing. It started back in the 80s. The original 3D printing was made. They started creating patents for all the various different technologies. And from the 90s to about 2008, you saw all kinds of really cool stuff. But it was really expensive, and most parts were not strong at all. It wasn't really until 2009 when the patents started to expire and companies said, hey, I can make something that does that. And there was an explosion in companies not only creating 3D printers, but people using them. And what we start to see is in about 2014, they were everywhere, but anyone who tried to use them generally felt them to be overpriced, not easy enough to work with, or just the parts just weren't strong enough. And so there was kind of this disillusionment, and it was picked up on by Markforged. That's when they started out. They saw an opportunity in the market to create printers that could drive immediate value, that are extremely strong. In fact, their first customer was NASA. They wanted to send the most stiff, strong, and lightweight parts imaginable into outer space, and they built the machine that would do exactly that. And what we've started to see since then is not just Markforged, but the entire industry has evolved and matured. And what you see now is we're seeing parts. In fact, today, the Dreamliner, Boeing Dreamliner, has 3D printed fuel injectors in the engines and the turbines. You're going to see more additive parts than you ever thought imaginable, and it's accelerating constantly. So where we are today, we've got several different companies with a proven track record of creating really valuable parts and a really valuable system to add in to your existing manufacturing processes. And that's where we are today. So if you've looked at 3D printing anytime sort of outside the last 5 years or so, it's time to look again and take a serious look at Markforged. It was established in Boston. It was some MIT graduates. They basically invented continuous carbon fiber 3D printing. A lot of people have tried to adopt or to copy some of the technologies, but we'll see a little bit later that there really isn't a corollary in the industry. These parts are really strong, really inexpensive printers relative to their counterparts in the industry, and they've created the world's largest fleet of online industrial printers. It's on a cloud, so everything is connected. Your data is secure, right? Just like your Gmail account is secure, no one else with a Gmail account can see it. But because everybody's working on the same platform, they can watch usage, they can get feedback from users on what worked well and what didn't, and they're able to rapidly innovate with the benefit of seeing real-time information from all of the users. So the 3D printing ecosystem is smart, robust, simple, and empowering. So let's talk about why you would want something that could do all that. And it's supply chain. Supply chains are expensive. They're slow. They are sort of, many, many steps of paperwork, but they remain and will always probably remain the best way to create high volume parts for full production at a low cost and highly reliable. But unique parts really struggle here. So whether you're talking about prototypes, you're talking about tooling inside your shop, guards and guides and jigs and fixtures, or it could be even repair parts. Those kinds of things are really, really tough to source. And so if you don't have that manufacturing capability in-house, or you have to do a big changeover to do it for things like low volume production, it really isn't going to be the best ROI, or it's going to be difficult to make it profitable for you. And that's where Markforged comes in. We want to help you solve those unique part problems by bypassing the traditional supply chain, which, as we all know, is very problematic these days. And we want to give you an immediate payoff on your investment in a printer. But that's not all. We also want to build a culture of creative problem solving within your organization. So what we're talking about is not that dip in ROI that you saw, coming up to 1920 or even after it. What you're going to see is an immediate ROI that's paid off in weeks to months instead of years to decades. And your ROI is going to multiply itself. You're going to be constantly getting more and more value out of this, and your company is never going to be the same. You're never going to look back. Let's look at some examples of what I'm talking about, who's using it, and what kind of success they've been able to have. So we'll start with the U.S. military. Wars have been won or lost primarily because of logistics. And with COVID and with just supply chain issues we're having right now, logistics is hard enough when you don't have people with guns trying to shoot you while you drive in and out of the work office that day. So getting a part into theater could take months. We're putting these on expensive military planes and airlifting them if needed. The supply chain is slow or non-existent for maintenance and repair operations, especially in theater. So what Markforged printers give them the capability to do is to provide highly critical parts at the point of need. So you could have a designer on site, or you could have a designer off site, basically creating the designs and validating them, and then that information gets fed into the machine and they print it right there and it's ready to roll. And they have a whole library of existing verified parts that they no longer have to keep inventory of. As long as they have their printer, they can just say, oh, this broke, give me a few hours or give me a day or two, I will make another one. So really fantastic use of, or illustration of the extreme supply chain issues you might encounter. MRO solutions, maintenance and repair operations, we're seeing a lot with this. And what you really benefit from is the ability to create something that's durable and strong, and you can iterate really, really quickly to get it up and running. And then once you get your prototype, it's a durable end-use, tool. So this innovation center in Orlando, for Siemens, they make huge steam turbine generators. They were responsible for supporting these turbines, but when maintenance was required, whether it was routine service or repair, there was downtime where they had to literally lift this turbine out of the building, disconnect it from the system, take it down there to get it fixed because it required specialized equipment they couldn't travel with, and then bring it back. And we're talking $250,000 for the lifting equipment and the trucking alone, not to mention the downtime for these critical pieces of equipment. So what they did is they started building these tools. These are saws that go through and grind or reface some of the turbines, and they're built very specifically with lots of guides and gauges so that it can work on site in place, and they can basically take it down for a day, hours, I don't know, run the maintenance and get it right back up and running again. So the ROI on these was absolutely stupid. They saved $8,000 for every prototype they did. They were able to perform and iterate tremendously faster. They could make as many of these as they need on demand, and absolutely saved a ton of money for them and their customers. Another company that, this isn't maintenance, but another company that's using it in-house is Wartela. So they have these huge steel castings, very heavy, and what they needed was a tool to be able to lift these engine parts. By the way, these are like drive shafts for massive ships, right? Cruise ships, etc. And so if you think about lifting up a massive casting, what you need to do is first put a hook on it. And to put a hook on it, you need some kind of, device mechanism that sort of grabs the part and has a lift eye at the top. Well, those are made of metal. And because of the size and the weight rating, they were very heavily built, which means they're so heavy that even the lift mechanism cannot be lifted without a crane, at least not safely. And so what they would have to do is go bring the crane over to where the lifting mechanism was stored on the shelf, pick it up and carry it to the casting, wait for the operator to hook it on, then they would carry it over to where they needed it to be for the next operation. They would drop it in place, they would disconnect, and then have to take back the fixture to the shelf. So what they ended up finding was, A, this thing was cheaper than even the commercially off-the-shelf available steel versions. They also improved worker safety because there was at no point were they trying to handle or manipulate something that was dangerously heavy for somebody to lift. They also found that it saved time on their crane operators. So think about this. Somebody says, hey man, our crane operators are going full out. We're considering adding a whole new crane or figuring out a way to make our cranes faster or more efficient or something like that. And somebody says, what about 3D printers? It's not the most obvious connection, but there are so many ways that you can solve problems and actually create major improvements in other areas. And that's that culture of creative problem solving that I talked about that you will adopt. This may not be your first application. This may not be your first print, but as you get going, you can get these built. And in fact, these, because they're safety, related, right, lifting overhead parts, they got them CE listed. So the regulatory agencies are jumping on board very quickly with these industrial grade parts and being able to get them out or use them internally. And you're not sort of breaking the rules. You're not taking a chance. These are safe and effective parts. So the digital forge is what drives all this. And there's three main pillars. It's enterprise level software, industrial 3D printers, and industrial materials. Now, you may think, oh, well, they're selling their own materials. They're just trying to, make all their money there. These are not overpriced materials, but they are extraordinarily high quality materials. And because they are constantly innovating both in terms of how the printers print, the speed of the print, occasionally they reformulate some of their materials. And when they do, the software, the printers, and the material availability happens simultaneously. There's no downtime. There's no question of, do I have it right? You've got apples to apples, and you've got direct line of communication between all three of these, which means if anything goes wrong, you have a single source of accountability where we will be able to help you get back up and running and fix their problem. The hardware is kind of the star of the show for most people, but it's only one piece of the puzzle. We've got different grades, different levels of machines. So starting on the left, that's a desktop printer. It's basically as big as a large inkjet printer or a laser printer. So if you've got one or two engineers and they're doing work either for design or supporting a manufacturing environment, this would be fantastic to set at their desk or put in their area, and they would be able to do a ton with this. I've seen companies do some really amazing things with it. If you need more capacity, if you don't want to have to maintain a bunch of small ones, if you're looking for something with more automation, with more sensors, so you know it's going to run well and it can run even more lights out than the desktop, then you can go up to the X7 or the Industrial series. They have bigger beds. They have stronger drive motors, so they're going to be able to print much, much faster. And they do a lot of the same materials. So it's sort of like just the bigger version, right? The printer / copier that is in the supply room or the break room, as opposed to the 50 inkjet printers scattered around the office, right? This really helps to collect everything. And both of those are very reasonable size. The FX20 on the right, this is where you get into the serious production level capacity. The quality on these parts is unbelievable. The materials, extraordinarily high strength, high temp materials that, for example, can be used inside aircraft, things like that. And then we've got a Metal X we'll talk about later that's kind of in that top level category. So along with those printers, we have various materials. So the top row, these are your polymers and your fibers that are going to go in your desktop X7 and FX20. Carbon fiber, Kevlar, and fiberglass are the three main continuous fibers. We'll talk about exactly how they go inside the part and what makes them special. But carbon fiber is your maximum stiffness, maximum strength. It tends to be more expensive, of course, but it's a really powerful grade of fiber. Kevlar is one that's really tough. So if you've got something that's on a shaker table, you're sticking this thing on a dirt bike, anything where there's going to be impact or something like that involved. I used this recently to create a dead blow hammer, for example. Found out that a lot of manufacturers are doing the same thing. They're just using Kevlar inside of 3D printed parts to build, in some cases, production dead blow hammers. And fiberglass is kind of your all-around performer. It's lower cost. It's still strong and stiff, but not quite as strong and stiff as the other two. Those are going to be embedded inside of a polymer. The polymer base is a nylon 6, which is a very durable material. But if you embed chopped carbon fiber pieces in that and mix it, you create what we call onyx. And onyx is much stiffer, way more dimensionally accurate and stable. So it creates a fantastic quality part. So you've got Onyx FR, which is flame retardant. You've got an electrostatic discharge variant. And then for the FX20, that high temperature material, the Ultem 9085 filament is really, really strong and powerful polymer. And then you also have a PLA option. So, for example, on your desktop printer, you can print in a low-cost PLA to get your prototypes done, and they're colorful, so they're kind of great for things like color coding things within the factory, handles, things like that. On the metal side, we've got 17-4 stainless steel, which is a great all-around material. Inconel 625, if anybody's worked with Inconel, they know it's extremely hard, extremely tough, and you can't really build intricate parts out of it because it's so strong, it's hard to cut. But we can build very intricate parts and details. It's almost even better and faster than any other method available. Then we have 3 tool steels, H13, D2, and A2, depending on what you need, whether it needs to hold an edge or it needs surface abrasion resistance. There's some variations in what those do. And then pure copper, which is fantastic for thermal and electrical applications. So for example, EDM sink patterns or heat sinks, things like that. So the PLA, the onyx, the carbon fiber, what it allows you to do is start quick and cheap. PLA is quick and cheap, and you can print it and basically hold it up and say, does it fit? Does it even sort of the bolts line up, right? Once you get the shape down and you immediately have something that's at least semi-functional, then you can start iterating and say, okay, well, if I did it like this, I could lose weight. If I do it like this, it's easier to assemble and it's quicker to print. And then once you feel pretty confident that you've got that part done, you can step up to onyx. And that's where you can start to actually put it into production. You can load test it and see if it's strong enough. If it's not, you can add some fiberglass, some carbon fiber. You can increase the density of the interior of the part. You have full control. With one design, you have full control over the strength and stiffness of that part. And you can actually go into initial production with this, meaning you can delay your tooling purchase until the market has had a chance to look at it and decide, yes, this is something they want, or maybe this isn't quite what we need to do a design change. Thank goodness we didn't buy tooling yet. So the process, if you're not familiar, of continuous fiber reinforcement, it starts with a 3D model. We can handle any CAD package you may have, and you start slicing it layer by layer. So for each sliced layer, we will go in and trace out the walls, trace out the floors, and those will all be solid, but then we'll put sparse fill on the interior, and then you get to choose where to put the continuous fiber reinforcement. You can cover the whole plane and make it, throughout, which would be great for like a sandwich panel, or you can put it around the edges like this one that's really going to give the part a fantastic strength to weight ratio. This is what it looks like when it prints. That's one continuous piece of, in this case, Kevlar that's traced around and around and around. So there is no sort of failure point unless you literally break the material. That continuous fiber reinforcement brings your plastic parts to a completely new category of performance. So on this chart here at the bottom right, this is stress versus strain. And if you see nylon, ABS, even onyx that has those carbon fiber, chopped carbon fiber in it, those are all relatively soft. They're great for a lot of things, but they don't compare to things like metal. That's where you need the fiberglass, the Kevlar, or even the carbon fiber. They're going to take these plastic parts like bones inside flesh, and they're going to give them tremendous strength capabilities and stiffness capabilities. And we're seeing people replace metal parts all over the place. You'd be amazed at what is possible, and we can talk about what you might need to look at to see if this is a bit good use for you. Metal 3D printing is another area that they expanded into. What they did is they took their experience and knowledge from extruding plastic filament, and they created basically a bound metal powder. That bound metal powder is deposited the same way a polymer 3D printer would work. It's built up layer by layer with a ceramic release. So if you need to build a part and you need to have it sort of separate between two faces, you need to have something in the middle that can break away. The wash process, that's where they debind and kind of remove the binding agent. The debinding agent then needs to be removed, so those parts are dried in another compartment in the wash station, and then they're ready to be sintered. So you collect them up, put them on a build plate, and load them up. This same type of sintering process is used in high accuracy parts like gears. It starts out by kind of removing the last of the binding agents that are in there, and then once those have dissolved, it ramps up the heat, solidifies all the metal powder into solid metal, and this is something that gives you an extraordinarily strong, durable, and very dense part. You're going to be able to create metal parts in one piece that normally would have either taken extremely intricate machining and costly fabrication, or would require an assembly of multiple parts. That wouldn't be as strong as a single solid part would be. How strong? Well, it's metal. So a lot of times people ask us questions about our materials, and when they ask about our metals, it's really easy. Go look it up on Google, and what they say there is what we've got too. So depending on how you process the metal, that will make some differences. So for example, casting or metal injection molding is not going to be as strong as a Mark Forged 3D printed. We have a really, really fantastic density of our solid parts. About the only thing you can do to get better than a Mark Forged part in that metal is to have a forging built in that metal. And forging is definitely an option for the highest possible strength and toughness, but this is a really awesome high-speed version of creating that part. And again, you can make it in almost impossible shapes because of the 3D printing additive aspect. So next we'll talk about software. The software is called Eiger. So if you ever hear Eiger, that's what we're talking about. And it really brings a modern ecosystem to this modern equipment. It's smart, connected, accessible, and scalable. So what does that mean? The software itself runs on the cloud. If you need an offline version, they have it, so you can keep it ultra safe and stay disconnected from the internet. But basically, you just import your part, put it where you want it, and it'll immediately tell you how much it's going to cost. It's going to show you the interior details, so you can decide, do I want my walls to be thicker or anything like that. This one is a metal part, so there's no continuous fiber reinforcement inside of it, but we will be able to see exactly what's going on. Then we can print it in our printer, either one off, or we can fill the bed up and create several at a time to do it in a batch. And it will run unattended. Because it's cloud-based, you can use any browser to get on it. So, for example, your cell phone. I'm constantly checking the progress or acting on anything that needs to be done from my cell phone if I get an email. And a lot of times I'll be sitting at dinner with colleagues and they'll say, oh, awesome, my part's done. And then they'll know that when they get back to the office, it's going to be ready to roll and they can start planning their day. The tools are also connected back to the Markforged servers. They're extraordinarily secure, like military-grade security, but the usage that you use and the feedback that you provide goes into an artificial intelligence algorithm, and it's constantly making the parts better. So as we go through and start building things, or if you are to do things like scan and feed back into the system the results, you don't have to tweak your process. The AI will tweak the print. So in other words, if you build a particular shape and you find that every time you do it, it's 10 thousandths bulged or 10 thousandths warped in a certain direction, we could scan that, put it back in, and then it would offset that. Meaning you wouldn't have to go and modify your model or cheat your model to get it to print correctly. The software will take care of that for you. It's pretty amazing. Speaking of scanning, we have Blacksmith. Blacksmith is an automated end-to-end in-process quality control software tool. It's built inside Eiger, and so if you just check the box that says, go ahead and scan this for me, you can set up exactly how much you want it to be scanned, and there is a micron resolution laser fitted into the print head. So after every print layer, that laser will go back and make sure everything is where we expected it to be, and it can measure faces that are, for example, interior faces. Imagine if you had an interior void that was impossible to inspect otherwise. You could inspect that as you go with this. And probably one of the most impressive things about it is when the print is done, it'll tell you not only, hey, the print is done, pick it up and take it, it's also going to email you the quality report telling you with confidence that that part was printed exactly as you'd expect, and it'll show you all of the deviations from what you expected, and you can make an assessment right away about whether that part is ready to go, and you can use it immediately. If you start to scale up, as you start to kind of get more printers, or you have printers in different office locations. By the way, that's a fantastic way to share your production. You literally put it on Eiger, make sure it's working, and then you say, hey guys, if you ever need this part, no matter where you are in the country or in the world, just grab it out of Eiger and hit print, and that print is going to be perfect because it maintains all the settings that I used. But Eiger Fleet allows you to sort of say, look, I need 1,000 of these. Spread them all around on these printers, and it'll just go ahead and take care of it and tell you when sort of that 1,000 parts are done collectively from your entire fleet. So the scale advantage really helps to fuel Markforged. As we get more customers, we get better at making printers. We get better at getting feedback with customers with part data, especially things like Blacksmith. And that feeds back into the algorithm to make the prints and the printers smarter. The feedback that we get to sort of say, well, this was a problem, this one didn't work well, we can put that into continuous improvement, which gives us better parts, which gives us basically more customers. And we've seen this over the years. Each generation of printer that comes out is significantly better than the previous one, and they continuing to release new machines and new printers to address different capabilities. But they start all the way down at the desktop level, a very affordable 3D printer, and go all the way up to those industrial grade, basically production level machines. If you need to learn more, if this is your first foray into 3D printing, or you've never used a Markforged printer, we have workshops at the Markforged headquarters that you can go and attend. We also have on-premise training. A lot of times if you buy a printer, we'll actually come and help you set it up if you choose to have us help you. You can do it yourself, but if we come on site and put in the piping or anything that might be necessary for some of those industrial grade ones, we'll usually do training while we're there so that we can tell you not only how your machine is set up, but also how you would use the additive mindset to solve problems. And we also have Markforged University online. Fantastic way to polish your skills, learn more, and really understand not only how to use the tools, but even how to identify applications. So if you're not sure if you are sold on the idea that you need a Markforged printer, but you're interested in finding out, what you could use, you can go on there and learn about finding applications and then identifying them and performing an ROI to see if it's going to be a good fit for you. So Markforged, with the digital forge platform, the printers, the software, and the materials, it's built for today. It's built to give you an ROI for today, but it's designed to be a long-term impact on the profitability of your company. I hope you enjoyed this presentation. Feel free to reach out at any time and let us know what we can do to help you.